Hello everyone. We've been looking at congruency of triangles, congruent triangles for the past few videos, and we have an idea of what congruent triangles look like. So they have the same shape and same size. So two triangles are congruent if they have the same shape as well as the same size, and we also saw what it means geometrically. So say that these two triangles, if I had to prove congruent, I'll have to prove that first of all they have the same shape, that is they have the same angles. So this angle is equal to this angle, this is equal to this maybe, and this third angle we have is equal to this angle, and they have the same size. So this side should be equal to this side, this one should be equal to this one, and this side is equal to this side, right? So only then we conclude that the triangles are congruent. But we also saw that proving everything is the same, proving every measurement is the same, all 6 measurements is not necessary. We can just do with a few measurements. For example, we looked at the side angle side axiom of congruency. We looked at the angle side, or the side angle, or ASA, whatever you want to call it. So essentially two of the angles are equal, which means the third angle is automatically equal for a triangle, and any one of the sides are equal. So we are today interested in discussing another such shortcut without measuring all the 6 measurements, another such shortcut to find whether the triangles are congruent or not. So say that this should be the first thing taught actually in congruency, but we kept it for later because it, according to me, needs a slight bit more intuition. So maybe this is my triangle and the other triangle. So A, B, C and P, Q, R. I am interested in seeing whether if AB is equal to, or AC is equal to PR, AB is equal to PQ, and BC is equal to QR. If this is true, then does this imply that the triangles are congruent? Does this imply this congruency? Well, let us see. First of all, we need to change the question a little bit for our advantage so that we can just work with it, So if say that I have a triangle of some given 3 sides, say that the sides are 5, 4 and 3. So the question I'm interested in asking is this unique? Will this form a unique triangle? So is this a unique triangle? Is this a unique triangle? Unique triangle. So this is the question I'm willing to ask. If I answer this, if I say that yes, this will form a unique triangle, then if the sides of these triangles are known, if each of the 3 sides are known, then automatically we'll conclude that any other triangle of such sides are actually essentially the same triangle and they are congruent. But if this is false, then we are in a problem. So let us just see that given 5, 4 and 3, how many triangles can I construct? So for this, let us go to my other scene I have set up. So this is a compass tool I found online. So say that I have a triangle of side 5, 4 and 3. So I'll draw this now. This is a triangle of side 5, and I have to somehow this is a line, and I'll have to construct a triangle on top of, using this as a base maybe, of dimensions 5, 4 and 3. How many such triangles can I construct? So taking a compass, I'll keep the ruler here, and taking a compass, I'll measure 4 centimeters. This is centimeters, I believe. So I'll measure 4 centimeters. I may be a bit off, but it wouldn't matter, right? So this is 4 centimeters, and I'll go and place this compass over here, and I'll draw an arc. So wherever the arc is, will show me what the 4 centimeter radius will be from, right? This whole circle will have a radius of 4 centimeter. So no matter where I cut the arc, I'll be at a distance from 4 centimeter from this point, right? So now what do I need? I need a 3 centimeter arc, because the next side is 3 centimeter. So I'll measure 3 centimeters now, and I believe this is, I cannot get more accurate, so I'll place this over here. I'll draw an arc. Do you see what happens? So it cuts the arc at 2 separate places. So maybe we are in trouble, maybe. Let us see. So I'll join it with a red line. So this is one triangle. So I've got the third corner of the triangle essentially. So this is maybe one triangle, and this is another triangle. But do you see what's interesting here? If you just look at this triangle, this angle, both are equal, and these two angles are equal, and this angle is equal, right? So essentially what we have got is the same triangle flipped on the other side about this axis, this 5 centimeter line axis, right? It has been flipped. So with 5, 4 and 3 as measurements of our sides, 5, 4 and 3, we are able to draw only one triangle up to triangles being congruent. As far as we are concerned, this is a single triangle because this is of same shape and same size. So only one such triangle exists of 5, 4 and 3. Hence, if I find any triangle of 5, 4 and 3, so say that this was of 5, 4 and 3 units, so we'll be able to conclude by the proof we have just shown you that triangle ABC is congruent to triangle P. Well, order is very important, because so first we'll write the side of length 3 AB. So AB will be congruent to PQ. So PQ and R. So this can be concluded because we have proved this. So automatically all the angles will be equal. I hope you get the point. And so now we have another list, another axiom in our tool bag, if you will. So this is another such axiom, and there is one more axiom that people learn. I'll just tell you what the axiom is, and you as a homework will just have to, you don't need a paper and pen for this, you just have to think about it, and you just have to say that whether we have already looked at this axiom in some other form. Using all this, you'll have to say that whether this axiom is satisfied. So the axiom is, if you have a right angle triangle, so let me draw a right angle triangle for that. Oh, so these are scalene triangles, right? I'll pick a right angle triangle tool. Yeah, this is a right angle triangle, and this is another right angle triangle. This is another right angle triangle. So if I say that this angle is 90, and I say that the hypotenuse is some distance, say that it is 10, and some other side, so these both hypotenuses, hypotenusae, whatever you want to call them, are 10, and this is say maybe 3 or 7, it can be 7. So if I have this much information, can I conclude that these two triangles are congruent? Think about this. If you should mention that, you should at least you can mention in the comments that if this problem is easy or not, if you have thought about it and you have the answer. But a hint would be, this is very close to my SSS axiom, and you'll have to apply a very famous theorem somewhere. Anyway, that's a lot of hints, but if you can prove it, then very well. If you cannot, I'll be posting a next video on the proof of RHS and why it is the same as SSS. So Hope you understood. Thank you.